large reptiles already capable of doing damage, may be more dangerous than anyone thought. The plot is playing out right here in Florida.
For years, we thought the Burmese python was just an oversized snake loose in the Florida Everglades. A predator, an invasive species. A problem that could be hunted, trapped, or eventually wiped out. But hidden inside these animals was a secret far more dangerous than their size or strength. Now, scientists have finally analyzed the DNA of the invasive pythons spreading across Florida, and what it reveals isn't just alarming, it's terrifying. Because this isn't simply a story about snakes.
Burmese pythons have done unprecedented damage to the ecosystem in South Florida, and experts say these invasive snakes continue to move farther north. Typically, these apex predators are found in areas like...
It's a story about rapid evolution, biological adaptation, and an invader that may be changing faster than we can stop it. What researchers found suggests the Everglades isn't just being overrun, it's being rewritten at the genetic level. A predator, you don't hunt, you survive. You do not hunt them, you survive them. Deep in the swamps of Florida, something has changed. Camera traps placed in the Everglades were meant to document a slow ecological collapse, but instead, they captured something far more unsettling. The pythons are still there. They still dominate the water and the sawgrass, but they are no longer the only story. What has been unfolding in this flooded wilderness is not just an invasion. It is a turning point, one that forces scientists to question everything they thought they knew about control, adaptation, and survival inside this broken paradise. We know how the Burmese pythons arrived. The trail leads back to the exotic pet trade, a pipeline of animals imported faster than ecosystems could understand them. When Hurricane Andrew tore through South Florida in 1992, it flattened a reptile breeding facility near Miami. In the chaos, hundreds, perhaps thousands of snakes escaped into the wild. At the time, it seemed unthinkable that they could survive. A tropical snake, loose in a harsh, unpredictable wetland? Most experts believed the cold would kill them. Others assumed they would starve. Almost no one imagined domination. They were wrong, because the Burmese python was not just surviving. It was evolving into the perfect apex predator for the Everglades. A Burmese python begins its life small enough to fit in the palm of your hand. Within just a few years, that same snake can stretch beyond 3 meters and weigh more than 22 kilograms. And that is only the beginning. Fully grown individuals have been documented exceeding 6 meters in length and tipping the scales at more than 90 kilograms, heavy enough to overpower adult deer. These snakes are not fast chasers. They do not need to be. They are ambush predators, perfected by evolution. Their camouflage allows them to vanish into tall grass and muddy water so completely that even experienced hunters walk past them. They can remain submerged for more than 30 minutes without breathing. Along their jaws are heat-sensing pits that allow them to see warm-blooded animals in total darkness. To a python, a raccoon glowing with body heat is a beacon. Escape is not an option. Then there is reproduction. A single female Burmese python can lay up to 100 eggs at a time. With no natural predators capable of controlling their numbers, the population didn't just grow, it exploded. Today, scientists estimate that between 100,000 and more than 300,000 Burmese pythons now inhabit South Florida. The Everglades, once alive with movement and sound, has begun to fall silent. The numbers are almost impossible to believe. In heavily invaded areas, raccoon populations have collapsed by 99.3%. Opossums are down by 98.9%. Bobcats have declined by nearly 88%. These are not gradual losses. These are near eradications. An ecosystem built on balance is now tilting toward collapse. But the Everglades learned a different lesson. You don't hunt these animals, you survive them. And what the cameras captured in Florida's swamps proves the rules of this ecosystem have been rewritten. The war, Florida thought it could win. Florida responded the only way it knew how, by declaring war. In 2013, state officials launched the Florida Python Challenge, a public call to arms inviting anyone brave or reckless enough to wade into the swamps and hunt the invaders. Cash prizes were offered, including a $10,000 reward for the person who removed the most snakes. The event became annual. By 2024, more than 800 participants from across the United States and Canada arrived armed with traps, snake hooks, and nerves of steel. That year, 195 pythons were captured. In 2025, the number rose to 294, a new record. The headlines were triumphant. The photos were dramatic. It felt like progress. But the math told a different story. Even at the lowest population estimate of 100,000 snakes, removing a few hundred represents less than 0.3% of the total population. If the true number is closer to 300,000, the impact is statistically invisible. It was like trying to drain the ocean with a spoon while the tide continued to rise. The Everglades did not recover. It simply became the backdrop for a hunting competition. Recognizing the scale of the failure, the state escalated. The South Florida Water Management District hired professional hunters, paying them to patrol levees and wetlands year-round. Since 2017, these contractors, combined with state, federal, and private efforts, have removed more than 23,000 pythons. It was an astonishing achievement. And still, it may represent less than 5% of the population. For every python captured, dozens more hatch and vanish into the endless sawgrass. The war was being fought with determination, but against an enemy multiplying faster than bullets could fly. Frustration set in. Florida turned to technology. Drones equipped with high-resolution thermal cameras were deployed, hoping to spot pythons from above. But the Everglades are hot. The water is hot. The ground is hot. And pythons are cold-blooded masters of thermal camouflage. To a thermal camera, a resting python looks like a warm log or muddy puddle. Dense mangroves and tree cover sealed the failure. The drones were blind. Next came robotic rabbits, heat-emitting, sound-producing decoys meant to lure pythons into traps. The snakes ignored them. As ambush predators, pythons wait for real prey to wander close. Loud machines held no interest. One idea finally showed promise: the use of Judas snakes. Large male pythons were captured, fitted with radio transmitters, and released during mating season. Instinct drove them to breeding females, leading researchers to massive egg-bearing snakes. It worked, but slowly, expensively, and at a scale far too small to matter. And then came the unsettling whispers from the field. Hunters and biologists began to talk. Pythons seemed to avoid traps. They stayed away from patrol routes. Some Judas snakes led trackers on strange looping journeys for months, almost as if they knew they were being followed. A dangerous question emerged. What if the pythons were learning? Florida thought it could win this war with money, manpower, and guns. They launched competitions. They hired hunters. They celebrated body counts. But when scientists finally ran the numbers, they realized something terrifying. This wasn't a war at all. It was an illusion. When the cold failed evolution in real time. For years, scientists held on to a single hope: the cold would save us. Burmese pythons are tropical animals, evolved for the humid forests of Southeast Asia, and it seemed impossible that they could survive far beyond central Florida. Winter, many believed, would draw a hard line they could not cross. Then, the winter of 2009 to 2010 arrived, bringing weeks of unusually cold temperatures that transformed the Everglades into a frozen graveyard. Tens of thousands of Burmese pythons died in a mass die-off that stunned researchers, with images circulating of frozen snakes draped lifelessly over branches, roads, and canals. For a moment, it looked like a turning point. It looked like victory. But what scientists discovered in the aftermath was far more unsettling. Follow-up studies by the United States Geological Survey and the University of Florida revealed that the python population did not collapse. It rebounded, and it rebounded quickly. More disturbingly, it was no longer the same population. The snakes that survived the freeze had changed, retreating into underground refuges, hiding in drainage systems, and occupying deep burrows dug by gopher tortoises and other animals. Some survived through sheer chance, while others likely possessed subtle genetic traits that allowed their cells to tolerate cold stress better than their ancestors. This was natural selection unfolding in real time. The cold did not end the invasion, it filtered it. The result was a new generation of Burmese pythons capable of tolerating colder conditions than anyone had predicted, rendering earlier climate models obsolete. Updated projections now show suitable python habitat extending well beyond central Florida, while the ecological damage left behind continues to deepen. Long-term field studies document catastrophic declines in mammals such as raccoons, opossums, foxes, deer, and bobcats, with even juvenile alligators no longer completely safe. Yet, the most terrifying consequence of the invasion was not the size of the pythons, but what they were carrying inside them. The invisible killer, riding the invasion. While performing necropsies on Burmese pythons, researchers began noticing a disturbing pattern hidden deep within the snake's lungs, a parasitic crustacean known as Rayleigh orientalis, a type of lungworm native to Southeast Asia. At first, the discovery did not raise immediate alarm because pythons and this parasite had co-evolved over thousands of years, allowing the snakes to carry the worms with relatively little harm. They were adapted. Florida's native snakes were not. The danger became clear when biologists began examining native species such as garter snakes, pygmy rattlesnakes, and water snakes that were found emaciated and struggling to breathe. When scientists opened their lungs, they encountered a horrifying sight. Dozens, sometimes hundreds, of tiny worms clogging the airways. The parasite's life cycle proved to be terrifyingly efficient. An infected python defecates in the swamp, releasing lungworm eggs into the environment. Cockroaches and other insects consume the waste, frogs and lizards eat the insects, and finally, a native snake eats the infected amphibian or reptile. Once inside the snake, the larvae burrow through the stomach wall and migrate directly into the lungs, where they feed on blood and tissue, reproduce rapidly, and slowly suffocate their host. Infected snakes grow too weak to hunt, gradually starving while struggling to breathe. Researchers have documented severe pneumonia, open bleeding lesions, and in some of the worst cases, snakes with worms crawling from their mouths as they gasp their final breaths. At least 18 native snake species in Florida have now been confirmed infected, with the parasite spreading across dozens of counties and advancing north toward Jacksonville and the Florida Panhandle. As native snakes disappear, the food web begins to unravel. Rodent populations surge, birds of prey lose a critical food source, and the ecological balance collapses further. Scientists began asking a question that once seemed unthinkable. If this parasite could jump from pythons to garter snakes, why wouldn't it spread further? They once believed the parasite would never leave its original host either, and that assumption has already proven fatal. Why we can't eat the enemy. Faced with an invasion that seemed unstoppable, many asked a simple question: why not eat the pythons? Why not turn the invaders into a resource? The answer lies in poison. Research conducted by the United States Geological Survey and the Florida Fish and Wildlife Conservation Commission revealed that Burmese pythons in the Everglades contain dangerously high levels of mercury. While the Environmental Protection Agency considers food unsafe above 0.3 parts per million, python meat from the Everglades averages between 2.0 and 3.5 parts per million, with some individuals exceeding 5.0. In one particularly alarming study, 100% of python tissue samples exceeded mercury advisory levels, meaning not a single snake was considered safe for human consumption. This contamination is not random. It is the result of bioaccumulation. The unique chemistry of the Everglades allows bacteria to convert inorganic mercury from rainfall and pollution into methylmercury, a highly toxic form that easily enters living tissue. Algae absorb it, insects eat the algae, fish eat the insects, raccoons and juvenile alligators eat the fish. And at the very top of this chain sits the Burmese python. With each step, the toxin becomes more concentrated, saturating the python's muscles and organs. The snake is no longer just a predator, it is a mobile storage unit for poison. Consuming python meat carries severe health risks, including neurological damage, tremors, memory loss, and impaired motor function. with pregnant women facing the greatest danger due to the risk of birth defects and long-term cognitive impairment in children. Because of these risks, Florida officials issued a clear warning: do not eat python meat. Turning the invasion into food would not solve the problem. It would simply transfer the poison from the swamp into human bodies. And just as it seemed there were no viable options left, Florida announced a decision that stunned the world. They were going to release snakes. The emperor returns fighting snakes with a king. When Florida officials announced they would release hundreds of snakes into the wild to combat the Burmese python crisis, the reaction was immediate and explosive. Social media erupted with disbelief and mockery as headlines spread across the world, all asking the same question: had Florida completely lost its mind? After decades of struggling to contain one invasive snake, the solution appeared to be adding more. Fighting snakes with snakes sounded like the kind of idea history had already warned us against. Critics were quick to draw comparisons to some of the worst ecological disasters ever recorded. They pointed to Australia's cane toad, introduced in the 1930s to control beetles, but instead multiplying into billions and poisoning entire ecosystems. Others mentioned the mongoose, released in Hawaii to control rats in sugarcane fields, only to wipe out native ground-nesting birds when the nocturnal rats and daytime hunting mongooses rarely crossed paths. The internet declared it obvious. This was history repeating itself. Humans playing God again, about to make a bad situation catastrophic. But beneath the outrage and ridicule, something critical was being misunderstood. Florida was not introducing a new invader. It was restoring a lost ruler. The snake being released was the eastern indigo snake, the longest native snake in North America, and once the undisputed apex predator of the southeastern United States. Reaching lengths of up to 2.7 meters, the indigo snake is a powerful, non-venomous hunter with glossy blue-black scales that shimmer in sunlight and a distinctive coral red or orange patch beneath its chin. Yet, its appearance is the least important thing about it. What truly sets the eastern indigo snake apart is its diet. The indigo snake is an Ophiophagus species, meaning it eats other snakes, and it does so with shocking efficiency. Even more astonishing, it is completely immune to the venom of North American pit vipers. Rattlesnakes, cottonmouths, copperheads, the indigo snake consumes them all. It does not constrict its prey. Instead, it pins them with sheer jaw strength and swallows them alive, unharmed by venom during the struggle. In the forests and scrublands of the southeast, it was once the unquestioned lord of the food chain. Its historical range stretched from South Carolina through Georgia and Florida and west into Mississippi. But human activity dismantled its kingdom. Longleaf pine forests were logged into near extinction, and gopher tortoises, the burrow builders whose tunnels provide shelter for indigo snakes, were hunted, displaced, or killed in massive numbers. During the Great Depression, people dug tortoises out of their burrows for food and killed any snake found sheltering inside. By 1978, the eastern indigo snake was listed as threatened, wiped out entirely from Alabama and much of northern Florida. What the public saw as a reckless experiment was, in reality, the final stage of a conservation effort that had taken decades to plan. A coalition of scientists, conservation groups, and state agencies had been breeding indigo snakes in captivity for years, carefully restoring longleaf pine ecosystems and protecting gopher tortoise populations before even considering reintroduction. Every release was tracked, tagged, and monitored. This was not desperation. It was precision. Still, the fear remained. What if this was another mongoose scenario? What if restoring an apex predator into an already collapsing ecosystem created a new imbalance? What if restoring an apex predator into an already collapsing ecosystem created a new imbalance? What would indigo snakes eat once they ran out of prey? And the question no one wanted to ask out loud, could they even eat Burmese pythons at all? Scientists insisted the risks had been studied extensively, but history had taught the public to be skeptical. The emperor had returned to reclaim his throne, but the battlefield was already burning. And then something happened that no one expected. When the swamp fought back, while the world was distracted by the snake versus snake controversy, something far more surprising was unfolding deep in Florida's wetlands. Nature itself had begun to adapt. In Big Cypress National Preserve, researchers were tracking a massive male Burmese python nicknamed Loki. The snake measured nearly 4 meters in length and weighed approximately 23 kilograms, and it had been fitted with a GPS transmitter as part of a long-term breeding study. One December morning, scientists went to check Loki's signal, expecting a routine update. Instead, they found his body stretched lifeless across the grass. Loki's head had been completely severed and carefully hidden beneath pine needles nearby. This was a fully grown apex predator. Something had hunted it. Initial theories pointed to alligators or panthers, but days later, a nearby trail camera delivered a revelation that stunned biologists. The footage showed a native Florida bobcat feeding on the python's remains. The bobcat weighed less than 11 kilograms, less than half the python's mass. It was the first documented case of a native bobcat successfully stalking, killing, and feeding on an adult Burmese python. For over 2 decades, pythons had been the unquestioned monsters of the Everglades, feared by nearly every animal in the swamp. Now, suddenly, the balance had shifted. The home team had scored, and this was not an isolated incident. New observations revealed that American alligators, apex predators shaped by millions of years in these wetlands, were stalking and killing juvenile and subadult pythons. Field footage confirmed mutual predation rather than complete displacement, suggesting the early formation of a predator-prey balance rather than total ecological surrender. Even the endangered Florida panther, elusive and rarely observed, had been recorded confronting large snakes, signaling behavioral resistance rather than avoidance. Smaller species were adapting too. Birds adjusted nesting locations, mammals altered activity patterns, and prey species began reshaping their behavior to reduce overlap with pythons. These changes did not undo decades of damage, but they revealed something extraordinary: resilience. This was not just footage of death, it was footage of learning. Biologists began asking uncomfortable questions. Could predators be observing one another? Could a bobcat learn from a failed hunt and pass that knowledge to its offspring? Could behavioral adaptation spread faster than population decline? One wildlife biologist described it as a win for the home team, but with a grim caveat. One bobcat cannot erase 2 decades of devastation. For every python killed by a native predator, thousands more hatch and disappear into the sawgrass. The Everglades had landed a blow, but it was still losing the war. And that is why what happened next mattered so much. For years, conservation groups had been releasing captive-bred eastern indigo snakes into a protected region of northern Florida, known as the Apalachicola Bluffs and Ravines Preserve. This area lay hundreds of miles north of the main python invasion zone, but it was the ancestral homeland of the indigo snake. Every individual was tagged, tracked, and monitored. Survival alone would have been considered success. Then, in the fall of 2023, trail cameras captured something extraordinary. 2 juvenile eastern indigo snakes appeared on camera, wild-hatched and moving confidently through the undergrowth. They were the offspring of adults released years earlier. For the first time in nearly 50 years, eastern indigo snakes had successfully reproduced in the wild in northern Florida. This was not survival. This was revival. Biologists confirmed that one of the juveniles was untagged, proving it had been born entirely without human assistance. The emperor was not merely clinging to existence. He was raising heirs. As 2024 and 2025 passed, the story grew even more hopeful. Researchers documented additional snakes, including a healthy male nearly 1.8 meters long, gliding confidently through restored habitat. 19 other released individuals were also identified, all thriving. The key to this success was not the snakes alone. It was the land. Decades of slow, difficult restoration work, reviving longleaf pine forests, and protecting gopher tortoise burrows had rebuilt the foundation of the ecosystem. The system was no longer just repaired. It was functioning again. Still, realism is necessary. Indigo snakes are not a silver bullet. They are currently being released far north of the Everglades, while python strongholds remain hundreds of miles south. The 2 species are not yet colliding, though one day they may. But that is not the true significance of this story. The real, unexpected consequence has 2 sides. First, Nature is adapting. Native predators are learning. Second, a conservation strategy rooted in patience, humility, and respect for natural balance is working. For decades, the Everglades represented human failure. We failed to control the pet trade. We failed to contain the invasion. We searched desperately for technological miracles, only to watch them fail. But the solution was never drones or robots. It was restoration. The Emperor had to return. The three-sided war. At first glance, the story appears to be turning toward hope. Native predators are learning. A lost king has returned. The land itself is beginning to function again. But beneath that fragile optimism lies a far darker reality. Because the Everglades is no longer facing a single enemy. It is facing three. The first is obvious. The Burmese python, still reproducing at a scale no predator or hunting program can meaningfully contain. The second is invisible. The lungworm, a parasite spreading quietly through the ecosystem, killing native snakes from the inside out and advancing northward faster than anyone predicted. The third is the most complex of all, restoration itself, a gamble that depends on timing, balance, and luck. These three forces are now moving toward each other. Burmese pythons continue expanding north as cold tolerance increases through rapid natural selection, while eastern indigo snakes, restored to their ancestral range, slowly push south as habitat recovers. Between them spreads the parasite, indifferent to borders, immune to good intentions, and devastating to species with no evolutionary defense. The collision is no longer hypothetical. It is inevitable. This raises the nightmare scenario scientists are only beginning to discuss quietly. What happens when the eastern indigo snake encounters the lungworm? Unlike pythons, indigo snakes did not evolve alongside this parasite. They have no known resistance. If they consume infected prey, frogs, lizards, or even juvenile pythons, they may become hosts themselves. If that happens, one of the most carefully planned conservation victories in modern history could turn into a tragedy. Imagine restoring a species for decades, only to lose it to a parasite carried by the very invasion it was meant to help contain. Imagine watching a king return, only to be poisoned by an enemy no one can see. And yet, doing nothing is not an option. Without indigo snakes, without restored predators, the Everglades remains locked in a one-sided collapse. Pythons continue to erase mammals. Lungworms continue to spread unchecked. Rodent populations explode. Raptors starve. The system unravels piece by piece. Intervention carries risk, but inaction guarantees loss. This is the brutal truth of ecological warfare. There are no clean victories, only trade-offs. For decades, the story of the Everglades has been framed as a cautionary tale of human arrogance. We imported animals without foresight, destroyed habitats without restraint, and assumed technology could fix what carelessness had broken. When the crisis arrived, we searched for fast solutions, hunting contests, drones, robots, and miracle cures, and watched them fail one by one. What is happening now feels different, not because the threat is gone, but because the response has changed. Nature is adapting in ways no algorithm predicted. Bobcats are killing pythons. Alligators are reclaiming their role. Panthers are no longer avoiding snakes. Behavior is shifting. Knowledge is spreading through ecosystems the same way it spreads through families and generations. This is not eradication. It is resistance. At the same time, humans are finally learning to slow down. The restoration of the eastern indigo snake was not loud or dramatic. It took decades of habitat repair, patient breeding, careful monitoring, and acceptance that results might never come. When success finally arrived, it did so quietly, captured on a trail camera, 2 juvenile snakes moving through the brush as if nothing extraordinary had happened. But perhaps that is the point. Ecosystems do not heal with applause. They heal with time. Still, optimism must be cautious. The python population remains vast. The lungworm continues to spread. Climate change introduces new variables no model can fully predict. What we are witnessing is not a victory. It is a contest. A slow, grinding, evolutionary arms race playing out in real time. The future, written in the swamp. So what happens next? At some point, the northward march of the python and the southward return of the indigo snake will intersect. When they do, the outcome will not be decided in a single dramatic battle, but through countless small encounters, failed hunts, infections, survivals, and deaths. Some indigo snakes will likely die. Some pythons will fall. The parasite will exploit every weakness it can find. What determines the future of the Everglades will not be strength alone, but adaptability. The species that learn fastest, that change behavior, that survive long enough to pass on those lessons, will shape what remains. We often ask whether humans can fix what we broke. The Everglades suggests a different question. Can we step back enough to let evolution do what it has always done, while intervening just enough to prevent total collapse? For the first time in decades, the answer may not be no. The footage coming out of Florida's swamps does not promise salvation, but it does offer something rarer: proof that resistance is possible, that ecosystems are not passive victims, that even after catastrophic disruption, life searches for balance. The Everglades are still wounded. The invasion is still real. The parasites still spread. But the system is no longer silent. It is responding. And that response, fragile and uncertain as it is, may determine whether this story ends as a warning or a turning point. So we leave the swamp with a final question, one that remains unanswered and perhaps always will. Are we witnessing recovery, or are we simply watching the next phase of an ecological apocalypse unfold in slow motion? Tell us what you think below, and if this story changed the way you see invasive species, adaptation, and conservation. Don't forget to like, subscribe, and join us for the next journey, because the Everglades are still fighting back, and the outcome has not yet been written.